Hi, hello. Now we are going to see about the part 2 of the topic Boolean theorems and proofs. Under the Boolean theorems, we are having 5 postulates given by Huntington. He defined some rules. First one is called as your postulate number 1 is your closure axiom, and postulate number 2 is called as your identity axiom, which is given as for addition operation it's 0 and for multiplication it's 1. And postulate number 3 is your commutative axiom, that is your on addition it's x plus y, that is equal to your y plus x, and on multiplication xy, that is equal to your yx. And postulate number 4 terms as your distributive axiom, so which is called as your x into y plus z, which is equal to your xy plus xz, or x plus yz is equal to x plus y into your x plus z. And postulate number 5 is called as your inverse axiom, which is x plus x dash is equal to 1, and for on multiplication grounds it's x into x bar is equal to 0, where this 1 and 0 is called as your identity elements on the addition and as well as in the multiplication. So what is in theorem is a formula or a statement that is derived from the postulates, and the basic theorems of Boolean algebra are first one is called as your theorem number 1 is your x plus x which is equal to x, and your x into x which is equal to x. So it looks straightforward but needs to be proved. How it can be proved is the proof of an x plus x which is equal to x. We have to use the Huntington's postulates. Show that if a question has been given as x plus x which is equal to x, what you want to do is for that x plus x you have to multiply and 1, so x plus x into your 1 using your postulate number 2b, which is given as your under multiplication. When you multiply any number with the identity element of 1, which will give the same element, so your x plus x when it's multiplied with an identity element of 1, it can be given as so x plus x into 1. Now by using your postulate number 5a, a number and its inverse is equal to 1, so what you can do is x plus x into x plus s into this 1 is x plus x dash is equal to a number addition of sum of the number plus its inverse is equal to 1, so this 1 could be replaced by this x plus x dash. So when you multiply this by using your postulate number 4b, x plus y z which is equal to your x plus y into your x plus z, like that what you can do is x plus x into your x plus x dash can be given as your x plus x dash. So this x plus x into x dash can be given as your x into x dash can be given as your 0 as per the postulate number 5b. Okay, so your x plus 0 which is equal to your x. So such that with the help of on commemoration of these postulates of this 2b, 5a, 4b, 5b and 2a, we have proved that x plus x that is equal to x. And the next proof of this is called as your x into x which is equal to your x. So similarly, like the earliest proof, we have to use the Huntington's postulate, which gives the postulate number 2, 3, 4 and 5, and theorem number 1 is your x plus x which is equal to your x. Now what you do is x into x which is equal to x. So this x into x can be what the next step what you have to do is we have to add a 0 with this. So x into x plus your 0 by the postulate number 2a. Okay, by the postulate number 2a, when you add an identity element with the number, the number itself will be given out. So x into x plus your 0. Now to make that 0, okay, to make that 0, use the postulate number 5b. Okay, that is called as your x into x dash which is equal to 0. Instead of this 0, you put it as x into x dash. Now you take x in common from these two terms, so your x into x plus x dash. So this x plus x dash could be given as your 1. So your x into 1 which is equal to your x. Okay, so you have proved two things. One is called as your x plus x which is equal to x, and next one is called as your x into x which is equal to your x. Now there is another one proof called as your x plus 1 is equal to your 1. Okay, how this could be proved is, so x plus 1 which could be given as you when you pre-multiply that with your 1 into x plus 1 by the postulate number 2b. Okay, when a number is being multiplied with the identity element 1, then the number itself will come. So x plus 1 could be given as your 1 into x plus 1. Now instead of this 1, okay, instead of that 1 you could replace it by postulate number 5a, it could be given as your x plus x dash into your x plus 1. Now by using your postulate number 4b, okay, by using your postulate number 4b, x plus y into your x plus z is called as your x plus y z. Like that, x plus x dash into your x plus 1 is called as your x plus x dash into 1. So this could be given as your x dash into 1 is called as your x dash. So your x plus x dash should be equal to your 1. Like the same way, we can prove that theorem 2b, which is called as your x into 0 is equal to 0 by using the duality. And the one another theorem is called as your x dash the whole dash is equal to your x, x dash the whole dash is equal to your x. Postulate number 5 defines the complement of your x, so that is your x plus x dash equal to 1 and x into x dash equal to 0, which is given as under any arithmetic operation, okay, under any arithmetic operation. For example, if the arithmetic operation is an addition operation, when the arithmetic operation is an addition operation, then we can write as when a number x has been added with its inverse means, then it should be equal to 0. When a number x is multiplied with its inverse means, it should give the identity limit of 0. The complement of x dash is x, which can also be given as your x dash the whole dash, okay, x dash the whole dash, which is given as thus the proof. This is the proof of the theorem number 3. And there is one another property which we have to prove is called as your absorption property. So as per your theorem number 6a, x plus xy which is equal to your x, x plus xy which is equal to your x. Now what we can do is, so x plus xy which is equal to 6 means x plus xy which is equal to, with this x you multiply 1, okay, by the postulate number 2b, that is your x into 1 is equal to x, right? So like that, you instead of this x you write as x into 1 plus your xy. Now what you can do is, you can take your x in common, x could be taken as in common, x into your 1 plus y, okay, x into your 1 plus y. Now that is by using your postulate number 4a, okay, x into your 1 plus y, x into 1 plus y is called as your xy plus your xz. So in the next case, what you can do is you interchange between these two values. 1 plus y is interchanged as your y plus 1, 1 plus y is interchanged as your y plus 1. Like the previous one, proof of your x plus 1 is equal to 1, right? Like the same, your y plus 1 could be given as your 1. So x into 1 is equal to your x. So the property x plus xy is equal to x has been proved. Like the same way, we can prove the theorem number 6b, which is given as your x into x plus y which is equal to your x, which could be proved by the duality, okay, which could be proved by the duality. And what's your duality principle is, you have to replace, okay, you have to replace for the 6a and 6b, duality principle has to be used. As per duality, the positive sign, the addition arithmetic symbol of your plus should be changed to multiplication, and the multiplication is to be changed as your plus. So here a plus is there, so instead of that you move multiplication, and here between this xy you are having a multiplication, so that could be given as your x plus y, okay. So x into x plus y which is equal to your x. This is by your duality. By means of truth table, we can it is proved, okay, here. So x plus xy has been proved. And the next theorem, the fundamental theorem is called as your DEMORGAN'S theorem, which is given as x plus y the whole bar is equal to x bar into your y bar, okay, or else x plus y the whole dash is equal to x dash into y dash. And theorem number 5b is called as your xy the whole dash is equal to x dash plus your y dash. This could be proved by using the truth table, and this you would have already studied in the in your higher secondary physics, that too in under the semiconductor physics, after the logic gates. And there are few basic theorems that to be kept in mind. One is called as your postulate number 2a. Postulate number 2a is your x plus 0 is equal to x, and your 2b, so this side is completely dedicated for the arithmetic operation of addition, and this side is completely dedicated for the arithmetic operation of your multiplication. So x plus 0 is equal to x, and x plus x dash is equal to 1. So this is called as your adding with an identity element, and addition between an element and its inverse. And this theorem number 1, x plus x which is equal to x, and x plus 1 is equal to 1. And this property is called as your x dash the whole dash is equal to your 1, which property, this property is called as your involution property. and the postulate number 3 is called as your commutative, x plus y that is equal to your y plus x, and associative is your x plus of y plus z that is equal to parenthesis of x plus y plus z, and your distributive property is x of your y plus z is equal to xy plus your xz, and the DEMORGAN'S law is given as x plus y the whole dash is equal to x dash into your y dash, and your absorption property is x plus xy which is equal to your x. Like the same way, these are some, this is a duality between, okay, this side, this multiplication is just a duality. Okay, duality means your addition symbol is to be replaced by the multiplication symbol, and if you are having any zeros means that should be converted to 1. So x plus 0 means this addition symbol is to be changed as multiplication, and the number, okay, duality means changing on opposite, right? 0, instead of the 0 you put it as 1, the remaining are all same. So x into 1 which is equal to x, and here x plus x dash is equal to 1. So what you want to do is you can change it as this addition symbol should be changed to multiplication, and this 1 is the number, by a duality principle it should be changed as 0. Okay, and your x plus x which is equal to x means what you can do is your, instead of this addition alone you put it as your dot, so x dot x which is equal to x, and here by duality principle x plus 1 is equal to 1, so by duality principle x dot 0 is equal to 0, and for involution property there is no duality is there, only one side it can be proved. And here for this commutative use the duality principle, so xy is equal to yx, and here you can do it as x into yz which is equal to xy into your z, and here for this you can write as x plus of your yz which is equal to x plus y into your x plus z. Okay, and here this could be given as your x into y the whole dash is equal to x dash plus y dash, and here this could be given as your x, okay, x into x plus y which is equal to your x. That is the changing, how to get the duality from this column to this column is just in this column you have to make, instead of the positive signs you have to make it as multiplications, and instead of zeros you have to make it as your ones. Okay, but whereas the remaining, the parentheses should not be changed as per the duality principle. And such that with this we close the part 2.